Hello and good evening to all of you students from COP. It's wonderful to connect with all of you. Thanks for the thumbs up, Kunal and others, Sagar and everybody. It's such a pleasure to actually sort of teach innovation and creativity to all of you, and we would actually work together so that we would also pick up some projects and take things forward. So today is our introduction day. So we will look at how how we could basically understand all the creative processes, and then we will look at one small case study, and of course some introduction of the design school over here. So we'll start straight away. So let us go to the presentation. So here we are. So this is our design school in IIT Bombay. And students, it's interesting, right? The design school is generally more creative because we actually sort of get a lot of our thought processes from the arts field. And of course our engineering departments also are creative in their own way. But how can we enhance the creativity in our engineering students? So that's a big challenge. So we have some minor courses in design and innovation and creativity, and those help also to take the level of creativity of our engineering students from say 30% creativity to 70% creativity. We've done that with some small assignments and workshops. So this course, students, after you finish, you should all have moved from whatever level you are to at least 2 times that level in your creativity journey. So let us see how we'll achieve it. So here we are. So I have a very, very interesting journey. Let me introduce myself. So I actually graduated from the School of Design, IDC, IIT Bombay in the year 1988. And before that, students, I'm very happy to tell you, I was a mechanical engineer. So doing 4 years of engineering was great, right? We understood all the technological aspects, manufacturing aspects of mechanical systems and processes. And then when I came into the design school, we had a paradigm shift. And the paradigm shift was that we had to see the whole problem from another point of view. So that learning was really, really phenomenal. And and of course, this whole journey, kept on happening. Once we sort of changed the paradigm, our engineering doesn't go anywhere. So engineering is there. And of course, now there's a new paradigm where the user, the people with problems become more important. Not the engineering problem, but the actual problem of the people, right? That's very challenging. So let me quickly introduce you to the design school. We have 5 programs. The industrial design program where I graduated from. We have a communication design program. We have an interaction design program. We have a transportation design program, and of course animation. Very, very good programs in the MDes level, and at the BDes level we have one single program where all the students actually work on only a common foundation program for 2 years, and then they do whatever is of their interest in the next 2 years. So that's the whole challenge in which we take things forward. So students, it's very interesting that industrial design, we can go from crafts to wearables, from mobile phones to communication tools for the elderly. So the wide variety of projects are done. So what is the methodology for these projects? For example, for us, from a spoon to a car, the problem statement is the same. That's very interesting. The complexity is the same. So you need to understand that how can a spoon design to a car design be same. So that's the whole beauty of the industrial design aspect, that we learn this empathy towards the user. For example, if there's a spoon, for example, you need to find out what type of food you eat with that. You need to find out who is using it. It is no different for the car. So we don't get bogged down by the complexity of the car. We only are bogged down by the systems and surroundings and the empathy of the user. Let me quickly show you our communication design. Interesting. Look, in our country, as you all know, we do a lot of communication through videos, through graphics, through animation, and how much ever you do, it's still short. So a lot of that activity keep happening. We have interesting, aspects of user-centered design. We've been working on various projects which are user-centered. And of course, in the interaction design program, you all know this is a real program where you make your interface, your computer-human interface, very easy to use. You all should know that even just the e-commerce website, the way you build your website will get you more customers. In fact, it's very clearly researched, and a lot of research, information is available on this front for us. And of course, in the transportation design, our students are working from various levels of mobilities, from motorcycle, I've not put the cycle image here, cycles, bamboo cycles, cycle rickshaws, and of course multiple activities. It's such a wonderful field, and a lot of interest is there in this area. So students, please don't forget, in case some of you are very passionate about any of these disciplines, you're welcome to write the seed exam, and you can join the program. That's the plan. And of course, in the animation, as our colleagues, my colleague Professor Shilpa Ranadesh would always tell me, Jaku, in our country, even the Hanuman looks like Disney. The Hanuman doesn't look like the Hanuman what we know from our spiritual context. So it's very important to get our own traditional imagery, own traditional animations into the fold. So that's a very big challenge. So from there, now we have this very interesting journey of mine, where I was always wondering, why can't we take student projects to market, right? We've got a lot of design ideas, wonderful design ideas. And then with this endeavor, we approached our sort of alumnus, Sudhakar and Suresh Shinoy. They were very magnanimous in giving us the grant of around $200,000, around ₹1 crore, and then we built the Shinoy Innovation Studio. There's a studio which was been inaugurated nearly in 2010. The old picture, and we call our whole endeavor innovation by design. So you design the innovation process, and you basically you use design for innovation, and it's like a Mobius loop, so you have to go together. Now we have a very interesting thought process for us. We have a very interesting problem in hand, right? We are engineers, right? We are engineers, and we need to have our core engineering strength. If I had a lot of courses in design, maybe our engineering education is not complete, right? So if engineering education is not complete, how can I be a good engineer? I need to be a good engineer, and I need to also be creative. Then I also need to be innovative. And when you to become innovative, we'll have some good examples here. We'll check out what needs for innovation. Today, for example, the whole world is expecting things to happen very fast and very quick. That's a very big challenge we are facing in our whole journey. So here, for example, I was very fortunate. Remember my biodata? So I basically, graduated from IIT Bombay, and was picked up by Larsen and Toubro in the year 1988. And I designed that first petrol pump for them, which is the Z-Line petrol pump. That was the innovation, coming from my strengths in mechanical engineering, strengths in understanding electrical circuits, strengths in understanding product organization, and of course the design strengths of aesthetics from the design school. And here we have a very interesting journey of mine, which along the course we'll be seeing how we created serial innovation. Every 10 years or 8 years, we created new products which were runaway success. We'll discuss that in our serial innovation journey. And of course, these are the products in more closer view here. And we have the bullet dispenser, and of course the oval dispenser, and then we have so the whole journey, as introduction, I thought I'll just show you my three challenging projects. We have a very interesting syllabus. I like the syllabus a lot. There are a lot of aspects on creativity. There's a lot of aspects on working on various aspects. So I'll just go a little bit fast on this, and then I always show a case study through which we'll understand all these concepts. So that will be our right approach. So students, we all know creativity is the ability to develop something original, of course, and particularly in response to an idea, and I also added an aesthetic flair here because we're from design, and we said that, it should be beautiful, right? It should be endearing. It should be, of course, delighting the people who use it. So creativity has these multiple connotations, and we all know it's something original and something different and something great, right? Something very, very useful and something which can really delight you. So then what is innovation? This is very interesting again. When I say delight, I cross the boundary of idea to actually implementation something. So that is the issue of implementing a creative solution, something new, and realize the value to the other. So basically here you're not doing it for yourself, you're creating something new, and you are actually creating value and delighting a large number of, in fact I had this large number of users, but I have a lot of critic here. People say, "Arey, large का क्या जरूरत है? एक को भी किया आपने, एक को भी benefit किया, why not?" So that is also a challenge. So for me, I feel innovation should be for a large number of users so that it has got large, activity. So if you have, so this is the, level of innovation we talked about. For example, you can look at how, we all now know, how fossil fuels are getting very, very, thing, and now all the engines are shifting from, fossil fuels to electric engines. And that's a great innovation. And today, for example, I must tell you, I must confess with you that I have a Nexon EV. And before Nexon EV, I was driving an old Land Rover because I'm a designer, right? I have a passion towards vehicles. So I picked up an old Land Rover at very low price, which is broken down, got it, really repaired it, and I'm using it. And to my surprise, I of course sold it now. My electric EV is actually better than my Land Rover, which is like supposed to be the most rugged, most powerful machine. In fact, the electric EV is like so agile, it is so easy to use, it is economical, it doesn't make any noise. If you add all the attributes, there are so many delighting attributes that you just cannot miss it on the roads. And another very interesting thing caught my attention. My own professor, electrical engineering professor, asked me, "Chakku, ये लोग इतना charging stations नहीं है करके क्यों तकलीफ ले रहे हैं? You are charging your vehicle so easily on your home. This whole media euphoria that you need charging stations for your electric vehicle is actually wrong, because your charging stations are needed only when you go outdoor, right? When you go far off and you need to charge in the middle. But when you're in the city, you don't need the charging station. I charge my electric EV in the night, like the way I charge my mobile." So he himself was surprised that it is such an easy thing, and I was not thinking about it. So this is the user perception, which becomes very, very important for all of us to realize. And then we are always worried about these apprehensions and perceptions. And students, that is the biggest challenge for our bottlenecks. That's the biggest challenge for our mind block. We have mind blocks which are so strong that they don't let new ideas come in. So how do we break those things? How do we work towards new ideas and new innovations is our learning objective. So, for example, you've seen this new bendable screens from LG. It's of course a technology innovation, right? There's so much of work happening. And in all these technology innovations, there are at least 5,000 to 10,000 researchers, and maybe another 10,000 product developers, and maybe another 7,000 manufacturers or 10,000 manufacturing personnel who are working behind to create these type of technology innovations. it will be mind-boggling. For example, if you just look at the research papers which will go into make this bendable screens, they'll run into thousands, and they'll run into 10 years or more. So we have to value research for technology, in a very, very big way. And of course, we have, invention, which is actually a very, very, interesting word again. And it's invention could be a totally, novel product which will completely disrupt. Today, disrupt is a big word. So, innovation can disrupt, new things. It can disrupt new problems, and it can disrupt the current situations and come up with new ideas and come up with novel and different solutions. And of course, we can think of multiple inventions which are there everywhere today. For example, of course, we all know this very standard examples of how from filament bulbs we went into LED lighting, which is a phenomenal disruption. Because of this disruption, so many other technologies became feasible. So many other situations became feasible, and because of that aspect of of course, you're getting new aesthetics, you're getting less. Today I can live on a solar panel. 5 years back it was not possible to live on a solar panel. But then, why are we so slow in adapting? This is the big challenge, because we are stuck in the old habits. So creativity has to leapfrog and bury old habits and look for new habits of use. So that becomes very, very challenging. And of course, we designers and innovators have a very big role of how these new technologies, like for example, how these disruptive technologies are also as comfortable as the older ones. For example, the LED lights are very harsh. How can I diffuse them better? How can I have that, how can I have very different type of fixtures for them? So that's a big lesson for all of us to work. And today I'm very happy to tell you that a lot of my alumni from the design school are actually making lampshades. There are 4 companies now. Bamboo lampshades, terracotta lampshades. Can you believe somebody who can survive only by making terracotta lampshades? That's my student, Sanbit Golui, my first batch student from IIT Delhi. I taught in IIT Delhi for 6 years after I left L&T, and that was from 94 to 2000. And Sanbit was one of our first batch students. He worked in Godrej, he worked in Desmania, wonderful consulting houses, and today he has his own large company called Craft Lippy in Calcutta. And then he's churning out wonderful, sustainable products, of course, using these wonderful technology, LED lights, solar panels and all. So that is the beauty of how we can move today very, very quick. And similarly, we have this wonderful technology, which is the iPod. That's a very favorite technology, like REL. And students, I was in Japan in this company which in Sharp, and they were telling me that this technology which iPod used was in Hitachi, which was their neighbor, whereas Apple came all the way from the US, picked up the solid state technology and used it. And whereas what was Sharp doing? Remember, Sharp came up with this Walkmans, which is small. They were going miniature Walkman. 500 staff of Sharp in Japan were actually working to miniaturize the Walkman. And here there is a technology which is because of the technology, it is miniature, it is small, right? And and then the Sharp couldn't sell any of their new products after that. The whole division had to dissolve. Just imagine. That is again, a good example of how you're actually digging deep in technology, you're digging deep in miniaturization rather than looking at an alternative technology to miniaturize your product. Or look at alternative technology to make your product successful and better. You must have all heard about brainstorming. It's one of the sort of group exercise by which efforts are made to find a solution for a specific problem by gathering a list of ideas, spontaneously by members in the group. So there's a lot of, it's a group activity. So you make people sit in a group and you work on the group. I'll show you some images of how we do brainstorming. So students, we have decided we only 1 credit course, right? 1 credit course is 1 hour a week, and we lost some time already, a couple of weeks. So my plan is, if I put 10 students together as a group, and we all put very little time, can we come up with an innovation? I believe we can, and I'll show you some very good examples later on the YouTube. So we are planning to make a group of 10 people. Now, how will the 10 people make a group? So students, you have to really plan. You have to be very selfish over here. This learning came from a very interesting, senior professor from, Stanford, who teaches entrepreneurship. His name is Lyons, and he said that when you're making groups, you have to make groups with people who have different types of skills, different type of disciplines. So here, for example, in your group, you have to have, at least one from a different discipline. One means out of the 10 people, 5 have to be from different departments like electrical, mechanical. You can't have the same department all the 10. Okay, so 5 to 6. It will be very good if 2 of you come from various departments. All 10 of you are from different departments, the best. But you do that, and we'll be working, online to do this. So today you will be, for our, assignment, whatever we do later on, you could do it in 10 groups. I know Anish is finding it very tough to do it, but today with WhatsApp and some, we'll have some team leaders coming in. No, we'll have some team leaders coming in, and and there's some fire going over there on the thing. I don't know how to take meaning from what you're mentioning, and so that will be great fun to work, because if all of you can put in your right skills, whatever skills you have, we can, I think, do justice to this course. Otherwise, the type of time allotted to us is too short. So we'll plan that activity nicely. So here we are in the brainstorming activity now. So of course, let me now start directly with this very interesting case study. Look at this policeman. He is taking the rest of his stick, and it is actually hurting his back also. And this Mumbai Mirror, immediately took a snap from the back, and this published it in the paper. So Mr. Sadanand Date was the commissioner at that time in Bombay. He was a good friend of mine, and I was in Canada at that time. And he said, Professor Chakravarti, can you do something for us? Can you make it more comfortable? Can you provide a seat for my policemen who are on bandobast duty? And look at the contradiction, students. Always there is contradiction. Are aap bandobast duty mein ho, you have to stand, and you have to get good view of everything, and then you also want rest, right? It's a very big challenge. So that is the whole thought process of how you need to provide these things. And let us see how we solve this problem later on. So here, for example, in the brainstorming, these are my students from, we run a minor course in design innovation at IIT Bombay, and these are students who have been given wicked problems. Wicked problem, jaise, arey yaar, we should not let even a single person die at the railway crossing. Kya karenge? You have to come up with a solution. You want to cycle in the rain, and you must not get wet, and it should be very easy to use. Things like that. So when 5 to 10 people get together, you can do really wonders. So students, you have to also look at the logistics. So when you do these type of brainstorming sessions, you can come up with wonderful ideas. You can come up with wonderful, mock-ups, wonderful prototypes, and of course those prototypes can go into production. And then each group, I think I also had a group of 8, I think, in this batch, each of them. And I'm used to teaching these huge classrooms, but at that time it was live. But even nowadays we are doing teaching through online mode, and we're able to manage some of these group discussions in a very effective mode. And here, for example, the first important thing is your ideas. How do they come to you, and what type of seats will you provide for the policemen? So let me go to the second technique. See, one was this brainstorming, students, with a lot of ideas, right? You work in groups, and you take in a lot of inputs. We'll go to the details later. Today was our first day where we talk about all the techniques, and of course, if you have time, please Google and check what's happening, and and get to understand this aspect much better. So the second one is my most favorite, because this is the technique for engineers, and this is the technique for product designers. Solving problems, posed in the analogical situation. So what we do is, each problem is imagined in a very different way. And I have a lot of examples to show you, in this case. For example, if I'm designing a letterbox for India Post, the posting slot, I will imagine a bird. अरे bird का beak होता है और उसकी माँ उसको beak में ऐसे खिलाती है, whatever. It gives food from the beak and the beak opens, so it's a very good opening. So my letterbox should have an opening which is like a beak of a bird. It's an analogy, right? And then my letterbox will be very welcoming for people to post letters. So that type of analogical associations can come in. And of course we have different type of analogies. And this again, every time I invent a new idea, from these analogies. I love this direct analogy. Imagine I am designing a new washing machine. So in the personal analogy, I take it like I am the washing machine, and if I am the washing machine, where are my clothes? So I'm going to eat the clothes. I'm going to chew the clothes, right? Oh, can I have a new machine which can scrub the clothes wherever there is so I need to have a scrubbing phenomenon. So that wherever it's very, very soiled, I can scrub. So see, one good idea. Then after I eat the clothes, it has to go and be washed. So washing is like my stomach. So there's acid, there are juices, there are multiple churning happening, and of course, mixing happening, and washing is happening. And what's happening with my intestines? My intestines are long. Students, tell me, by your chat, if you can type in, I'm not sure whether you can type in, how long is a human intestine? I don't think we can put a chat message there. Mrudul, how long on the mobile? You just check. How long? So generally, the human intestine is like, we're opening the chat. Just if you know any of you, it's very, very long. So, yeah, we can chat. So 1.8 meters. Wow, that's really, really long. Yeah, we can chat. Thanks. we could get your information. So just imagine if my clothes pass through these 1.8 meters of dryer, I'll get fully dried clothes in the hands. आज तो मुझे मिलता है नहीं spinning करके मेरा कपड़ा खराब भी हो जाता है spinning होके. So I have only one technology spinning. I'm not even thinking of it like technology like my intestines, which are absorbing, which are pulling away the water from my clothes, and the technology is available. You know this technology where there's an IIT alumnus who runs a company where he can dry sambar the day you cook into powder, and then when you add the right amount of water, 400 ml, back in the US after a month, your sambar, the aroma, the texture, everything is as it is. So we have got technologies for drying at that level. So if you use the intestine, a method, you can always do wonders. So just imagine, with this one personal analogy, I've invented a completely new way of drying for washing machines, which can be behind the door of the bathroom, and the clothes are coming out dry, outside the wall. It of course will occupy a large area, but that's the convenience which is coming in. So that is the personal analogy. And of course, remember the beak for the letterbox? The beak for the letterbox is a very interesting direct analogy. Mother is putting food in the beak, and I am putting letters in the letterbox. So it's a direct analogy. So that's one interesting analogy. And of course, the symbolic analogy also is very, very interesting. And where you actually make a symbolic analogy to a different activity. And of course, we have the the most fancy analogy, which is called the fantasy analogy, where you fantasize. जैसे for example, खुल जा सिम सिम बोले से दरवाजा खुल जाना है आपका. So I want to invent a new lock, which will open by my voice command. वो तो आ भी गया. So fantasy analogy is coming up with new technologies which are IoT enabled, and your door lock will open with your voice, your door lock will open with your finger, your door lock will open with your things. So you can now fantasize multiple things and look at how technology can support to do all these things. Of course, we did some very, very simple assignments with students. See, the design students, उनका तो जान creativity में है ना. So we have this very simple assignment which is called designing a 2-compartment plate. होता है ना, idli, sambar, chutney. Idli is here, sambar is one compartment, chutney is one compartment. If you design that plate and you give it emotion, you call it a caring plate, right? Then you consider those analogies of a groundnut, the shell is carrying the pods inside, you look at the lotus, and then of course, this is the caring plate, right? You build the plate. And the students built the plate, they made out of clay, they made out of paper, they made a mock-up model, and they made a working model using thermoforming. And this happens within 2 weeks from start to end. Similarly, there were students who want to make an elegant plate. So for elegant, what type of symbolic and direct analogies you're taking? This is a symbolic analogy. So you take an analogy of a swan, which is very elegant and poised and all. And then seaweed for him was elegant. And this is an elegant plate, right? Have you mapped? Look at the mapping. Are you able to see a relationship between the delicacy of the swan and the delicacy of the plate here? And of course, the colors also play a vital role. And then I must tell you, students, I went to Jindal. This is Jindal stainless steel. So they actually are making utensils for people, and I showed them these plates, and they were also zapped saying that, wow, how can you make, and I have some 20 plates like this. Every student made one plate. And here we have the third technique. So now we all know, for product designers and engineers, our synaptics is the technique for us. You either fantasize, you do direct analogy, or you do symbolic analogy like the swans, or you do fantasy analogy, or personal analogy. You'll be able to come up with these fabulous things. But what is the mechanism behind? Jab mein, when we take up, these sort of analogies, we actually fox the mind. How can a letterbox be a bird? How can be an eating plate be a swan? How can be a human be a washing machine? So as soon as this fox the mind, fox the brain is not creative, right? You're thinking of analogical associations, and that is the base value of this creative, direction. So let us come to lateral thinking. All of you have heard about this term? No? Lateral thinking and vertical thinking, right? So this is generation, idea generation technique where problem is approached by reasoning, using reasoning that is disruptive and not immediate. So you don't, in lateral thinking, you do alternative techniques and don't go deep into one technique. Like, don't do deep into one idea generation. So here, lateral is multitude, whereas vertical is go deep into the same thinking. Research, students, is lateral. You always, is vertical. You go narrow, 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 narrow. Right? Your engineering education is actually very lateral. You learn everything of electrical engineering. You learn everything of mechanical engineering. It's very lateral. So, for example, ideas which are generated through random stimulation, forced provocation, and challenging assumption. So you have to challenge assumptions. I was telling you from day one. And the stimulation, for example, can be random, which we discussed in our synaptics also, where you think of, like anything to anywhere to think of the solution which can come. And of course, you can compare, you can borrow, you can distort, you can randomize. In fact, there's a very interesting, I didn't touch upon De Bono, but you all heard about De Bono, right? De Bono, please. He was a phenomenal guy who actually, coined, who also worked on brainstorming, and he came up with multiple techniques. And some of the techniques he would say is make the strange familiar and the familiar strange. To make something familiar strange, what will you do? You will actually create situations where it doesn't exist, or it will exist in a new way. And when it exists in a new way, you think about new ideas. So we will do all those through good examples. Here I want to just touch upon all the techniques so that we are very, very clear with various aspects of the creative process, because you should know all the creative process. TRIS again is a fabulous tool, and it has universal principles of invention. And what they've done is they found out some structure for creative innovation, and they put in all the principles together. So, for example, if you need a particular idea, you can go and check in the idea map, and you'll get some 10-20 ideas. So here TRIZ is doing a wonderful thing. It is building ideas over ideas. There are already some inventions which have happened because of these reasons. And you're working in this area, you see all this and use those to build upon your idea. So you're building ideas on ideas, so which become very, very powerful. And that is the TRIZ model, which is very popular with engineers across the world. So, and of course, it's a very structured, way of building the ideas, and we will see, during our class. Maybe we'll get an expert on TRIZ to, tell us all about that. And the basis for TRIZ is that problems and solutions are repeated across industries and sciences. The same problem is repeated. So you see a problem which is solved in chemistry, may be useful in physics. Things like that. They're very, very challenging and very interesting situations. And patterns of technical evolution are also repeated across industries. Very interesting. Basically some of these things get repeated, so you can use these aspects to take things forward. And the innovations used scientific effects outside the field in which they were developed. So some of them, most of the innovations, even my own innovations, were borrowed from outside that field. For example, we designed one very, very interesting bicycle for Hero Cycles, for making it very, very low cost. And we borrowed the manufacturing technique of the car industry. Car industry में क्या करते हैं? They have these large presses and they press the parts. Whereas in the bicycle, they have to weld all the parts. So we created a deep drawn bicycle, and that deep drawn bicycle was half the price of the pipe welded bicycle. So here we took the manufacturing idea from a car industry to manufacturing bicycles for the largest bicycle manufacturing company, which is Hero Cycles, whose main gate looks like a highway. Trucks are coming in, trucks are going in, because they make around 10,000 cycles a day. Huge number of cycles across the country. So, for them, this would be the right technique. So that is the whole idea of how things, move forward. Okay, then we'll close by showing this video.
जहाँ पे खड़े रहने से ड्यूटी करना पड़ता है, वहाँ पे आप आसानी से अपनी ड्यूटी कर सकते हैं।
और जो ज़्यादा या 12 घंटे ऐसा ड्यूटी करते हैं उनके लिए काफ़ी अच्छा है।
I think I'm getting some questions. So every company or technology faces real life problems. As an engineering student, what are the resources exclusively for that, so that we can get exposure? Wow, very nice question. That is Anurag Patil. Anurag Patil, which engineering are you from? Quick. Mechanical. Wow, you're from my one of my colleagues say you are my country cousin, same engineering. So very good. So that's a very, very nice question. Every company or technology face real life problems. In fact, the real life problem for a company is to make money, right? Industries have to make money. So that's the biggest challenge for us. So to make money, they have to produce products which are very, very... So the whole company, all the people in the company, all the engineers have to be aligned to the purpose of the product which they are making. You can't say that it's not my job. For example, let me give you a small example from my experience. I was working in Larsen & Toubro, and the petrol pump we manufactured would be thrown on a tire from a truck because there's no forklift, and then after it is thrown on a tire from a truck, the glass would break, and then within the warranty period, the company had to, sort of change the glass. Huge amount of cost, right, students? And very big customer dissatisfaction. So when I became the designer, I said it is my responsibility. There is no forklift. If the petrol pump is thrown, then also the glass of the petrol pump panel should not break. So what did I do? I used a direct analogy. I said, why can't I use the same technology which cars use to fix the windscreen? So in the car, what happens? The glass is fixed in the windscreen inside rubber, so it's hanging. And I implemented that, and after 20 years, not even one glass is broken in the petrol pumps, because I just used the analogy from the direct analogy from the car industry, where on the roads they have small hits here and there, and nothing happens to the glass. So why can't I do the same technology? And to my surprise, by using that technology, my cost reduced. It was easy to assemble. Multiple aspects were used, and that became a very, very good involvement, and that is the beauty behind new design. So here, for example, we should never throw our problem as somebody else's. We should look at a possible solution, collaborate, and come up with options. So there we go, students. It's excellent, catching up with all of you, and all the best. And today you have only one job. Today's assignment is building your team, and actually looking at, if you can, Mrudul, what do you think we should the assignment we should give? Come. So so what should be what problem? We were thinking of sustainable solution, right?
Those goals.
Goals, sustainable, like SDG goals. Students, we want to give you an open invitation to work on sustainable, goals, SDGs, and come up with, any small intervention which will reduce the global warming. Small intervention, and that intervention has to be implemented. So that will be a project. It could be how to reduce water wastage. It could be how to recycle plastic. It could be how to create a new sort of device. So that, for example, I was so happy to see that whole of IIT now has foot pedal for water, and because of the foot pedal for water, water consumption is reduced by more than 60%. Earlier, because I was using a tap, water was getting wasted. Now the foot pedal is very quick. I can put more force. So when I put more force, I get water, wash my hands, remove my leg, and water is gone. So 60% saving of water just because of a foot pedal. And water is so precious. So students, please think about that. But first thing is, please make your groups. By next week, I want your groups ready. And remember the groups. No one, you have to have at least one from each department. At least one. If there are two from one department, well, good. But not more than 3 from the same department. Maybe we'll put that rule also. Not more than 3 from the same department. Okay? Okay, then, all the best. Let us get your groups ready. I don't know how are you going to do your groups, but you remember, you're building your team by getting multiple skills. And I must tell you, team building is more important than even the problem. If the team is good, the problem can be solved. That is the entrepreneurial lecture which I had, just last month. Okay, students, bye. Have a great day, great evening. See you.